Well, sounds good.
Okay, in that case, I'm going to talk to you about the impacts of climate change on Arctic sea ice. So I'm Ed Blockley. I lead the Polar Climate Group here at the Met Office, and acknowledgement there to my various co-authors at NOC and University of Exeter and UCL. So firstly, I'm just going to briefly say what sea ice is and importantly what it isn't. Sea ice is frozen water. It floats on the surface of the ocean. It's formed from the ocean, and it only really happens in polar areas where the temperature is cold enough. Has a very large seasonal cycle, changes in the Arctic. The maximum is generally in March, which you can see here. This white shading is the seasonal average March maximum, and the orange here is the average September minimum. So it changes hugely throughout the season, but importantly, because it's formed from the seawater and it sits in the seawater, its decline is not impacting sea level rise. That is the land ice, mostly on Greenland and glaciers like that. So while we're talking about what the impacts are on sea ice, we split it into sort of three areas. One is the actual decline in the areal extent of Arctic sea ice. And then we've separately looked at other impacts within the Arctic of sea ice and other quantities. And then sort of new this time, we've put a bit of a focus on what might be the potential impacts of Arctic sea ice decline on Western Europe, along the lines of what might it mean to the UK. And as is true for, I guess, all the MCCIP reports, we're considering both the observed changes and the future projections. And all of this is tied quite strongly to the IPCC's most recent reports and consistent with those. So what's happening? What's happening in the Arctic? I mean, the big headline message is Arctic sea ice is declining. And you can see this picture here, which shows seasonal cycles of Arctic sea ice from January on the left to December on the right, over the full satellite record, 43 years. And these are decadal means. So the purple is the 1980s, and you can see how much higher that is than, say, 2010s in red. And this patch of red shading down the bottom is the trend. It's how much ice we're losing for each day of the year over the record, and you can see that the largest declines are in late summer, September to October. And we've seen at the seasonal maximum in September, almost 80,000 there, 79,000 square kilometres per year on average, which is roughly 4 times the size of Wales. So it is a large amount of sea ice that we have observed to be losing. And what can we say about that? The Arctic is warming twice as much as the rest of the globe. And the sea ice is strongly linked to the temperature of the Arctic, but also to atmospheric CO2 concentration and emissions. That's what this picture is showing here. Very high correlation between sea ice area on the y-axis and CO2 emissions. And so we can be confident to say that more than half of the observed sea ice loss can be directly attributed to greenhouse gas emissions, anthropogenic
so yeah,
influences.
TQ9.
Hello? So what else is happening outside of the sea ice aerial decline? The Arctic sea ice is thinning. The fraction of ice that survived more than a year is decreasing. The amount of land-fast ice, that's ice that is welded solid to the coast, is also in decline. The amount of snow sat on top of the sea ice is thinning, and because the sea ice is thinner and there's less of it, it's becoming more mobile. It's drifting faster, and the amount of it that is exported into the North Atlantic is also increasing. And then the marginal ice zone, so the area at the edge of the ice that is sort of broken up, marginal-looking ice, that is also widening. So it's not just the aerial decline. Other impacts that this might be causing, and the declining sea ice accelerating Arctic coastal erosion. This here is a picture of coastal erosion in northwest Canada. All those rates are positive, but the red much more so. There are impacts on the primary production and marine wildlife, so the amount of biology that's happening in the Arctic. And also, sea ice does affect the transport of nutrients and pollutants within the Arctic. So a lot of those are dragged off the shelves here north of Russia, transported by the sea ice across the Arctic, and those mechanisms are changing. And then briefly, the sea ice potentially affects remote weather and climate, which I'll talk a bit more about later. So the key facts, the top level facts are to show that the sea ice is massively in decline, has been for the full 43 year of the satellite record, approximately 79,000 per year in September, and that more than half of this can be directly attributed to us human beings, anthropogenic greenhouse gas emissions. So what could happen in the future? All models suggest that these current trends in sea ice area and thickness, most of the trends will continue and accelerate. And this picture on the right is showing the modelled future projections of Arctic sea ice decline in March at the top and September down the bottom for various different CO2 emission scenarios. And all of the scenarios will simulate at least 1 year of ice-free September before 2050 under all of the emission scenarios. But it does matter still what emission scenarios we follow, because lower warming will see fewer ice-free years and shorter ice-free seasons. And expanding that picture a bit, so that's on the right was the same as before, but now we're plotting sea ice area against CO2 and temperature change. And you can see there's a strong relationship between sea ice area and temperature or CO2. And so there are no identified tipping points associated with the Arctic summer sea ice. So if we reduce the temperatures and reduce the CO2, then the sea ice should recover. So a little bit about the potential remote weather and climate impacts, Arctic sea ice decline. And this is a picture here from the latest IPCC report. So evidence suggests that sea ice decline could possibly be felt in Northwest Europe, because as the Arctic is warming faster than the rest of the world, the temperature difference between the equator and the Arctic is decreasing. And the jet stream, which is a schematic picture of here, the jet stream is actually driven by that temperature gradient. So it could be affected, and it could slow down and follow a more wavy path, which is what's being shown here in this schematic. And this could therefore have an impact on storm tracks in the North Atlantic and potentially impact extreme weather events in the UK, like heat and cold waves or floods and droughts. However, you notice on the last slide I used quite a few coulds and possiblies and potential. So although the scientists are confident that Arctic sea ice loss could affect Northwest Europe, the size of that effect is unknown, and it's very much unclear how much, how the observed change of the jet stream, how much of those changes are caused by natural variability in the system and how much is caused by Arctic sea ice decline. And in fact, climate model experiments suggest only quite a modest effect of sea ice loss in the mid-latitudes. It's quite small compared to the variability we see there anyway. So, summary of the key facts for the future. It's virtually certain that the Arctic sea ice will continue to decline in response to warming. And in that regard, it's likely the Arctic will become practically ice-free in September at least once before 2050. But we're confident that it should return should we be able to reduce global temperatures and CO2. There are implications for changing the timing of sea ice formation. Could have implications for biology in the Arctic primary production, which could cause mismatch in demand for food and the habitat of marine species. So there's potential impacts on Arctic fisheries. And as I said, it's virtually certain the Arctic will continue to warm faster than the rest of the globe. So there is the potential that this could impact mid-latitude UK climate. And finally, just talk a little bit about the confidence assessments that Paul just mentioned. So we've split these up into the three bits, the three areas that I highlighted on the first slide. So the sea ice extent decline, the other components of sea ice and Arctic, and then the mid-latitude impacts. And really, the message is high confidence for the sea ice extent decline. It's beyond question that the Arctic is warming. It's virtually certain that the Arctic will continue to warm and that the sea ice will continue to decline in response to that. So what's happening and what could happen in the future for sea ice area, we've put as high confidence. Medium confidence for the other aspects of sea ice effects, because we have generally shorter observational records or discontinuous observational records and fewer lines of evidence. And then we've assigned low confidence for the mid-latitude impacts. So although there's good agreement that the potential is there to impact mid-latitude weather, there's low agreement between models, and it's hard to differentiate the observed changes from the natural variability in the system. So that's a brief overview of the report. Please go and have a read. Many thanks to everyone for coming to watch, and thanks to MCCIP for inviting me.